Good morning. We are now starting the second day of our international conference. Today, we will receive the keynote speech by Professor Elena Bartkiene. She is a doctor of physical sciences and chemistry, professor at the Department of Food Safety and Quality, as well as chief researcher and head of the Institute of Animal Rearing Technologies in Lithuanian University of Health Sciences. Her scientific achievements comprise 435 positions, including 123 original research papers in journals, 30 research papers in lower journals, 4 book chapters, 128 conference theses, 5 textbooks for students, 3 methodological books, 2 chapters, and also patents. The research areas are basically in food and feed biotechnology, safety and quality, molecular biology, sustainable biotechnology. She participated and has experience in coordinating and carrying out research projects. She is also a scientific expert of the Lithuanian and Polish agencies of sciences, and she will today be talking to us about berries, fruits, cereal, and dairy industry byproducts valorization by using lactic acid bacteria strains with antimicrobial properties. Welcome, Professor Elena Bartkiene. Thank you for your talk.
Hello to everyone, and very warm greetings from Lithuania to Portugal. And it's a big pleasure for me to be invited in this international conference. And today I will talk about berries, fruits, cereal, and dairy industry byproducts valorization by using lactic acid bacteria strains with antimicrobial properties. First of all, I would like to start from cereal industry byproducts valorization because wheat are the most popular crop at the world, and we have a lot of byproducts, and especially bran, which are valorized, not enough efficient, and till now, usually wheat bran is used like low nutritional value feedstock for animal nutrition. Also, we have another groups of byproducts, and this includes berries, fruits, and dairy industry byproducts. And for this byproduct group valorization, our group suggests antimicrobial properties possessing microorganisms to use and to develop modern biotechnologies for desirable antimicrobial compounds for food and feed industry preparation. But producing more food does not guarantee that people have the food they need for good nutritional status. And today we have very special challenges because we need to produce more functional food and feed as well. Also, we should increase antimicrobial and antifungal properties of different compounds. And when we're talking about cereal and especially cereal outer layer, it should be pointed out that cereal outer layer is a valuable source of functional compounds and especially lignans. But it's not so easy to produce functional ingredients from cereal outer layer because there are also non-desirable compounds like heavy metals and mycotoxins, etc. But when we're talking about functional compounds, I would like to point it out lignans, because in cereal outer layer we have some functional compounds, lignans, and in cereal we have matairesinol and secoisolariciresinol, which in vivo in mammals' bodies could be converted to enterolactone and enterodiol. And also in vivo we could convert enterolactone to enterodiol, which are functional compounds. And for this conversion, we need in our feces or digest microbial profile some specific strains, Peptostreptococcus and Albacterium. And our previous analysis showed that wheat bran could be a very good source of enterolignans for enterolignans production. And in comparing with rye bran and oat bran, the wheat bran is the best source for enterolignans. Also, it is not so easy to develop technology for this functional compounds production because extraction is not very good way because chemical structure of lignans is similar with mycotoxin structure. For this reason, we cannot use extraction because we also will concentrate toxic compounds. For example, mycotoxins. And our group suggests that full byproduct valorization is the best way for wheat bran valorization. And also including wheat bran to the main food formula, it's not so easy because by increasing quantity of wheat bran or another cereal bran, product quality is decreasing. And our group have a big collection of technological microorganisms, and the main microorganism in this collection are lactic acid bacteria. And we are using different fermentation schemas to valorize byproducts or to produce functional compounds, not just for food, but also for feed industry. And these microorganisms are characterized by their fermentation abilities to ferment different carbohydrates, also by the tolerance to temperature different and to low pH. And today we are participants of big cost actions or DOMEX. And I am leader of the group of project design and development in prototypes of products and small-scale processing technologies. And the main idea of this project is how to use bacterial strains, lactic acid bacteria strains, isolated from spontaneous fermented sourdoughs. And we are using this lactic acid bacteria, which are isolated from Lithuanian bread sourdough, for various purposes. For example, for food, feed, nutraceuticals, pharmaceuticals, enzymes, etc. preparation. But it's not so easy to apply fermentation schemas in food or feed industry and chemicals industry because usually substrate is contaminated with non-desirable microorganisms. And for this reason, our group suggests to use before fermentation decontamination of substrate by using extrusion. And by extrusion process, because we could decontaminate non-desirable bacteria and sometimes fungi, it's according to technology, extrusion technology. Also during extrusion, depolymerization of starch, denaturation of proteins, oxidation of lipids, and other processes could be obtained. And the main schema which suggests our group is for wheat bran valorization is first we should use extrusion, and then we can use fermentation with selected lactic acid bacteria strains. Why we suggest fermentation? Because previous our in vivo studies with piglets showed that by using fermented feed, it is possible to modify feces metagenomic profile to desirable way by increasing lactobacillus count in feces and by decreasing non-desirable microorganisms in digester. And fermentation of selected lactic acid bacteria also contributes to the production of amino acids, vitamins, organic acids, fatty acids, exopolysaccharides, polyphenols, antioxidants, etc., etc. But lactic acid bacteria metabolic activity is related to substrate specific. For this reason, always, if we have some bacteria, technological strains, we always should take into account that characteristic of the end product could be related to the substrate specific, and evaluation of the end product quality parameters is very important, and safety parameters. And in our previous study showed that, for an example, Lactobacillus casei and Paracasei strains inhibit 15 pathogenic strains, and this is very desirable property for technological microorganisms. But when we're talking about fermentation, usually we are thinking about functional, safe products, etc. But it should be pointed out that lactic acid bacteria, despite that they are generally recognized as safe microorganisms, could produce biogenic amines, which are non-desirable compound in food or in feed. But usually lactic acid bacteria could possess decarboxylase activity and could decarboxylate amino acids in fermentable substrate, and biogenic amines could be produced. Also, another challenge is this safety aspects should be analyzed when technologies for bioproducts valorization are created, is related to the occurrence of mycotoxins. But especially today, when analytical technique is very sensitive, we also should take in consideration emerging and masking mycotoxins. And of the 390 mycotoxins, about 270 are reported to occur in one or more food feed products. And in addition to the evaluated mycotoxins and their modified forms, because during fermentation, we never know, maybe from less toxic form could the mycotoxin be modified to more toxic form. For this reason, the end product safety parameters should be evaluated. And the main technology step you can see in this slide. And first of all, wheat bran was extruded by using different temperature regimes, and also different speed of screw was tested. And after extrusion, fermentation with Lactobacillus casei and Paracasei strains was used for wheat bran valorization. And to select the most appropriate technology, various parameters of processed and untreated wheat bran were analyzed: acidity parameters, microbiological parameters, concentration of sugars, free amino acids, fatty acids profile, biogenic amines, wide range of mycotoxin, and in addition, antimicrobial and antifungal properties of the treated and non-treated wheat bran were tested. And it was found that although lower pH was found by non-extruded samples, they contained a higher concentration of the minus isomer. Therefore, it can be stated that selection of appropriate extrusion parameters can lead to higher L+ isomer formation during the fermentation process with selected lactic acid bacteria strains, compared with non-extruded one. And according to lactic acid, science elevated levels of the minus lactic acid is harmful to humans. L+ lactic acid is the preferred isomer in food as well as in feed industry. As humans or in overall mammals, we have only L-lactate dehydrogenase that metabolize lactic acid, L+ lactic acid. Further, no enterobacteria were found in fermented samples, and extrusion decreased the total enterobacteria count in wheat bran samples, with the greatest reduction observed in wheat bran, which was extruded at 130 degrees at screw speed 25 RPM. And there was significant effect on the type of lactic acid bacteria applied for the fermentation and of extrusion, as well as interaction of these factors on total enterobacteria count in wheat bran samples. Summarizing amino acids results, some overall tendencies were established, and the concentration of all the amino acids analyzed increased during fermentation of wheat bran extruded at 115 temperature and fermented with both lactic acid bacteria strains used in this experiment. And the content of most of the amino acids analyzed increased in also the wheat bran, which were extruded at 130 temperature with screw speed 25 RPM and fermented with Lactobacillus casei strain. But if we have in substrate some amino acids, also biogenic amines could be formed, and these safety parameters must be taken into consideration and analyzed in the end product or ingredient. And in this our study, It was found that total biogenic amines content on average by 2 times was lower in extruded and fermented samples in comparing with non-pretreated wheat bran. And this could be explained by decontamination of wheat bran, because usually not just a lactic acid bacteria excrete decarboxylase enzyme, but also enterobacteria. And to decontaminate ingredients before technological processes is very important. And we found that biogenic amines could be reduced by using extrusion and then after fermentation process for wheat bran. And why we are talking about biogenic amines? They are natural compounds and they could be found in our bodies and in humans. Biogenic amines are involved in brain activity, regulation of body temperature and stomach pH, gastric acid secretion, the immune response and cell growth and differentiation, etc., etc. But when we have biogenic amines, especially histamine and tyramine, high concentration in food or feed, we can get problems because these biogenic amines are toxic. And also it should be pointed out that biogenic amines increase toxicity of each other. For this reason, we should evaluate as more biogenic amines than tyramine and histamine. For example, putrescine is also very important because they could increase each toxicity of each other. And biogenic amines accumulation in fermented foods is a complex process affected by multiplied factors and their interaction, and the combination of which are numerous, variable, and product specific. For this reason, we suggest control of the end product before the product stabilization, because if product is stabilized, that means it's frozen or moisture content is low, usually biogenic amines could not be formed. But when in product moisture content is high and product is not frozen, then biogenic amines could be found in such a products by decarboxylation of amino acids. And during the second step, fat acids profile was analyzed. And here we have a big discussion because some of the colleagues asking how you could explain fat acids, changes of fat acids profile. And this explanation could be like such. Usually, bacteria strains, not just a technological microorganism, but this bacteria cell walls contain trans fats. And by reducing, in example, contamination, like in this study, by using extrusion, we reduce the contamination with bacteria of wheat bran, and we reducing trans fats in overall profile of fat acid. And also during fermentation, some of technological microorganisms could produce monounsaturated, polyunsaturated, and other fatty acids. And for this reason, fat acids profile could be changed after these technological processes. And we found that these changes are desirable because we reduce saturated fat acids and fat acids and trans fat acids in fermentable substrate. And during the second step, mycotoxins were analyzed, and there was a significant effect on the type of lactic acid bacteria applied for the fermentation and of extrusion, as well as interaction of these factors on all the mycotoxin concentrations analyzed in wheat bran samples. And the lowest total indicated mycotoxin concentration was found in wheat bran extruded at 130 degrees with screw speed 20 and 25 RPM, and fermented with both lactic acid bacteria strains. And today we have a possibility to evaluate mycotoxins changes in vivo. We are participants and we are coordinating some Eureka projects. And during this project, we analyzed the mycotoxins conversion in vivo in young piglets. And the control group was fed with non-fermented diet. And treated piglets group was fed with fermented cereal bran diet, and it was found that alternariol, monomethyl ether, and altenuene were found in 61 days old control group piglets feces and in fermented feed samples. However, in treated piglets feces, alternariol, monomethyl ether was not found. And this changes lead to such a suggestion that by using fermentation for wheat bran, we partly detoxified mycotoxins. It's like first step of digestion, and these fermented products or ingredients became safer. Also, antimicrobial activity of wheat bran against a variety of pathogenic and opportunistic bacterial strains was assessed, and strong correlation between Staphylococcus aureus and Acinetobacter johnsoni, diameter of inhibition zones with pH and lactic acid bacteria count in wheat bran were found. That finally we conclude that this fermented wheat bran possessing antimicrobial properties, as well as 10 of the 15 wheat bran samples showed antifungal properties as inhibited from 3 till 7 out of 11 tested fungi. Also, by feeding fermented feed or for humans, by using fermented food, by consumption of fermented food, we can increase lactobacillus count in feces metagenomic profile. And experiment with piglets showed that although in both animal groups, the most prevalent genus remained Prevotella, the prevalence of lactobacillus was 6 times higher in the experimental group of animals. And this is very good results because usually lactic acid bacteria are the cerebral microorganisms in our digestion. And by increasing lactobacillus count, we're reducing another maybe non-cerebral microorganism. And from first part, we conclude that the combination of extrusion and fermentation with Lactobacillus casei and Paracasei strains can be confirmed as a prospective innovative pretreatment for wheat bran potentially capable of enhancing its composition, safety characteristics, antimicrobial and antifungal properties. And also such a type of wheat bran, extruded and fermented, it is possible to include to the main bread formula without decreasing of quality parameters, because sensory properties are also improved by using extrusion and after extrusion fermentation process of wheat bran. And second part of this presentation will be about berries and fruits byproducts, which represent an important source of available compounds. And we suggest that by using different combinations of compounds of different origin, plant and microbial origin, it would be possible to increase their mutual antimicrobial activity and also to reduce the dose of each compound. But we have some problems when we're using lactic acid bacteria, because lactic acid bacteria are sensitive to environment condition. And we should develop technologies for stabilizing of these technological strains. And for this reason, we developed technology for lactic acid bacteria encapsulation in whey substrate. And for encapsulation of lactic acid bacteria, biomass, Sauer whey substrate was used. Of course, with addition of some supplements, saccharose, yeast extract, and glucose, optimal quantities were selected and biomass was cultivated, and then encapsulation was performed. But first of all, combinations of fruit and berries byproducts with lactic acid bacteria strains were selected to produce antimicrobial activity possessing ingredients, coatings, etc. And in Lithuania, very popular are raspberries, blackcurrants, rowanberries, and apples. And we select, for this reason, these byproducts were selected. And the results show that lyophilized blackcurrant and apple byproducts showing possessing very high antimicrobial activity against various of pathogenic and opportunistic strains. Also, vacuum-dried apple possessing antimicrobial activity against Bacillus cereus, Streptococcus epidermis, Staphylococcus gametolyticus, and Pasteurella multocida. And during this step, it should be pointed out that bioproducts, fruit and berries bioproducts are not very stable. And we should use some technologies to avoid high moisture content in these products and very quickly, because they could be contaminated with fungi, yeast, and other microorganisms, non-desirable microorganisms. For this reason, in this study, lyophilization and vacuum drying at plus 45 degrees was chosen, and antimicrobial activities of such a pretreated byproducts was tested. But it should be also mentioned that lyophilization is better method to dehydrate bioproducts in comparing with vacuum drying at plus 45. But lyophilization is very expensive, and from economical point of view, it may be not very promising at industrial scale. But if we are using vacuum drying at plus 45, it is also possible to get some functional ingredients which also possessing antimicrobial properties against some specific pathogenic and opportunistic strains. And here you can see inhibition zones of the tested lactic acid bacteria strains against pathogenic and opportunistic microorganisms. And from all these tested strains, 2 strains were selected for further combinations development. This is Lactobacillus uvarum and Lactobacillus casei. And inhibition zones of the berries, fruit products, and lactic acid bacteria combinations against pathogenic and opportunistic microorganisms you can see in this table, and in all the cases combination of berries, fruits with Lactobacillus casei strain show that higher antimicrobial activity, better properties in comparing with Lactobacillus uvarum strain. And here you can see how we start biomass growth of technological microorganisms in our whey substrate. And first of all, we select some supplements, saccharose, yeast extract, and glucose were added to the sour whey, and then lactic acid bacteria, selected lactic acid bacteria were multiplied. And after were spray dried, and after spray drying, spherical capsules were observed in all cases, and available lactic acid bacteria cell concentration in the capsules was found higher than 7 logarithm colony forming units per gram. And this means that such a technology for lactic acid bacteria, like technological microorganism stabilization and convenient use at industrial scale, is appropriate and also sustainable, because during the dairy production is big problem sour whey, because till now sour whey is valorized not enough efficient. And finally, berries and fruits byproducts can be promising ingredients for the preparation of antimicrobial coatings. The broadest spectrum of pathogenic and opportunistic bacteria strains inhibition was shown by lyophilized black currant and apple byproducts, and their antimicrobial activity can be enhanced in combination with the Lactobacillus uvarum and Lactobacillus casei strains. Finally, we should think about sustainable agriculture, including effective byproducts valorization. Thank you very much for your attention.
Thank you, Professor Elena, for your interesting talk. Now we should have some time for discussion and questions. So I open this small period for your possible questions for Professor Elena about this interesting topic, which showed us how to use and add value to byproducts from different food industries. Any questions from the audience, please? Wait for the microphone just a little. Thank you.
Good morning to everyone. And I would like to congratulate your presentation. It's very interesting, very useful, because in fact, when we have fermentation, we have a lot of different bacteria working together, a lot of different products. Some of them are very good for our health and others are not. And in fact, you made a very good screening about all of this. My question is, do you analyze the Clostridium? Because some of them could be not very good in your products. Thank you very much again for your presentation. Okay. You listen me now? You hear me now? I don't know. Okay. Again, I would like to congratulate you for your presentation because it's, in fact, very nice and very complete. When we have fermented products, we have a lot of different bacteria work together and produce many different compounds. Some of them are good for our health, others are not. My question is, you analyze very different things and important things, but you analyze also the presence of Clostridium, because some of them could be a problem for the health.
Hello once again. I am very sorry because the voice is very bad quality. Maybe you could repeat the question.
Yes.
Do you hear me, Elena?
Yes.
Okay. What was being asked was about if you have analyzed the presence of Clostridium, because it is possible that some of the products that you have been analyzed could contain Clostridium. Was it?
Thank you very much for your question. Yes, also such a non-desirable microorganism should be included in analysis, but this our experiment was very broad, but Clostridium also maybe should be involved in this experiment. Thank you very much. Just it was first step on this technology, and we will include more analysis.
Okay, thank you. Does anyone have?
Okay.
We will have another question.
Yeah, this is another question. Małgorzata Korzeniowska, Wrocław University of Environmental Life Sciences. Thank you, Professor Bartkine, for such an interesting speech. This is actually a very crucial area now in the food science. And my question is, have you encountered any problem with the bitter peptides when you are analyzing your byproducts, especially regarding the whey, because our whey has lots of proteins still, and the bitter peptides can be a big problem when we want to implement or apply these byproducts or the preparations made out of these products into further food processing. Thank you.
Dear Professor Raquel, I would like to ask you to repeat this question for me, because maybe microphone is not very well working. Could you repeat?
Professor Malgorzata was asking about if you analyzed peptides, was it?
No, not peptides, not because we need some for peptides another analytical method, but now we are working on it. It was just amino acids and biogenic amines like products of amino acids degradation analyzed, but we're working on it.
The other question is that because you mentioned many like the actually contaminations, like biologically active amines or other carcinogenic substances. Do you have any idea, not exactly from your work, but like from the literature, how we can get rid of those substances? Yeah, the question is if you have any like ideas how we can get rid, for example, of mycotoxins in these byproducts.
How we can reduce contamination of mycotoxins, you mean? It is very difficult to say by 100% because now these analytical methods became very sensitive and we can evaluate a very broad spectrum of emerging and masking mycotoxins. And sometimes we can reduce lower toxicity mycotoxins, but we're increasing this more toxic mycotoxins in these bioproducts. But this study showed, because very broad spectrum of mycotoxins was analyzed, that total amount of mycotoxins is reducing by using extrusion and fermentation. But when we are analyzing technology, we should analyze very broad, because in example, the extrusion screw speed also have influence on mycotoxins degradation in fermentable substrate. And it is possible to reduce mycotoxins, but then product must be analyzed. Because sometimes during fermentation, product could become more toxic than before. And this is a big problem. For this reason, our conclusion in our group is that the end product must be analyzed and all safety parameters, as much as possible, safety parameters must be included for analysis.
Thank you, Professor Elena, for your talk and for your explanations. We now will move on to the next presentation. The next talk will be given by Professor António Dinish Ferreira from the Cernas Institute, Cernas Research Center from the Institute of Polytechnic Institute of Coimbra. António Dinish Ferreira is the head of this research center, has coordinated several national and international research projects, has expertise in environmental management, natural resources management, sustainable development, hydrology, soils, and desertification. With an H index of 30, seated 2,351 times, with more than 80 papers in international journals and book chapters, and more than 300 other scientific and technical papers. He was awarded the prize for Best PhD in Global Change, held in Portugal from 1995 to 2000, and won the Energy Globe Award 2006 for Portugal with a project in the area of environmental management. He coordinated a life environment project that was considered by the European Commission as one of the best life environmental projects in 2007-2008. Is involved in 40 research and development projects funded by the European Commission and the Portuguese government. So now we will listen to his talk. Thank you very much, Professor António.
Okay, first of all, I would like to thank this invitation. It honors me. It allows me to present some of my thoughts about this topic, which is very dear to me. I would like also to thank you for your kind of loose dress code. You know, not to wear a suit at this moment is a bit important for me because with the pandemic, I didn't do as much exercise as I used to do, so I put some weight. And if I have to to wear a suit, it would be quite a challenge to get inside of my suit. So thank you very much. Okay, sorry. That eases a little bit. So basically, what are we? These are my reflections about the theme, and I would like to do what we can call a spoilers alert, which is basically all that I'm going to present is either I worked about it in projects, help other people to submit projects, or I'm actually trying to get some financing by submitting proposals on these topics. So I will start to talk about the challenges ahead. Then I will revisit the traditional intersecting areas. These are basically not new, but the interaction between the environment and agriculture is a very deep one, and sometimes we forgot that the things can be managed in mutual benefit. I will speak about some mandatory relations in terms of environment and agriculture, some tools that are not new, but even so there's some scope here for some improvement, and then basically I will talk about what's really on the hot spot. What is, in my view, are areas which are very important that for the future they will increase efficiency, the productivity, quality, and is something that is basically I'm preparing proposals, for instance, for the Horizon Europe for the 6th of October call at this moment on some of these topics. I would like also to speak about something that I consider extreme agriculture, then the implications for business and employment, and then the conclusions. So basically, the challenges ahead between the environment and agriculture, as the previous person pointed out, we have one of the main issues is we have to feed very soon 9 to 10 billion peoples. And we have to do it in a sustainable way, which is a bit of a challenge because at the moment with the means and the systems that we are enforcing, we have very acute problems of sustainability. In addition, we have the climatic change problem, not only the question of extreme events, but also the question of the sea level rising. if you think about where the best soils for agriculture are, most of them are very low, close to the sea. And any rise of the sea level will impact the space that we have with best soils for agriculture. The soils may not be underwater, but the salinization of those soils will probably reduce their productivity. Then we also have a challenge on productivity and quality, and of course all this has to be economically sustainable. So to increase the impacts, new ways of business, new business models, and new employment opportunities have to be sought for. So we have some traditional intersecting areas between the agriculture and the environment. Basically, we have the question of air quality, and especially the emissions of pollutants and greenhouse gases to the atmosphere. And many times, especially animal husbandry has been, and especially cattle, has been pointed out as a major problem. But actually, agriculture and mainly agriculture can be managed as to reduce, as to be the problem-solving activity. Soils, either in agriculture or in forest, can be managed to act as carbon sinks. There are lots of projects about this. I'm actually finishing two European projects on this topic right now. We have the problem of fertilizers. Some of the fertilizers are a big problem for the future, especially if you think that some of the fertilizers are produced by came from petroleum, some of the inorganic fertilizers. And they are, for instance, potassium is not easily recyclable. So we are exploring the question of we are exploring the more judicious uses of fertilizers, and there are lots of research made on organic fertilization. We also have the problem of pesticides, and basically I'm also involved in another European project right now about basically how farming, and especially the use of fertilizers and pesticides, can impact drinking water. Basically, what we are getting to is we have actually to make a more judicious use of pesticides and fertilizers. For instance, I have to tell you that in Portugal is in the forefront of this. We have since 2013 legislation that actually shows, makes Portugal the only country in the European Union that actually reduced the use of pesticides, for instance. I'll come to this later on. and basically that is because there's a system that is connected to environmental management systems. It's basically the same structure, and it actually it's a good example of how this interaction between the environment and the agriculture does not reduce yields and reduces the amount of a production factor that is harmful and it costs, it's expensive. So basically, we are exploring this judicious pesticide use and the organic and also some other organic farming solutions like the sexual confusion and other the use of pheromones and things like that. So, and last but not least, we have the problem of water. And in the area of water, we have a few. Oh, great. You know, we are exploring the use of treated wastewater and more sustainable irrigation systems. So, as I said, one part of this relation of agriculture with the environment is of mandatory nature. So there are several environmental laws that actually impact the agriculture sector with the aim of reducing these impacts. So we have, for instance, since oh, this doesn't go. Oh. Sorry, oops. Since '97, we have some laws or law decree in this case that that influences the use of fertilizers. Since 2013, the question of pesticides. This law, as I told you, mimics the approach that are the structure of the environmental management systems, and it actually shows. You may not believe it, but we reduce, I think, by 1/3 the use of pesticides in the entire country, which is absolutely unaware of. And then we have things like the licensing of animal rearing activities and the environmental impact assessments that also influence the agricultural activities. So then we also have a set of tools for that from the agricultural, from the environmental area that can apply for that can apply in the agriculture sector, and that frame the agriculture sector. We have the certification systems. I point out here the one which was one of the first and is one well-known worldwide, which is the Test Good Nurture, which is a certification system that is very deeply connected with the agriculture. For instance, it sets for the rational use of plant protection products, rational use of fertilizers and organic matter, pollution prevention, protection of human health and working conditions, sustainable use of water, energy, and other natural resources, recycle and reuse, wildlife and landscape conservation and enhancement. You may think that they are very strict, but this is a way of showing to their quality to their consumers and to build trust between the consumers and the company. So Tesco, which would be, it's one of the major supermarket chains in the UK, doesn't do this because it got green. No, they do this because it increases trust and because it's good for business. And this has already arrived in Portugal in a bit, in a less deep way, but probably you've heard about, oh, my face is on top of it, but you, sorry. So, you probably heard about this, the continent. So slowly it's also getting to Portugal. Then we have this question of the life cycle assessment. Life cycle assessment is another tool. I'm not sure if I'm probably more than halfway. No, in time. About halfway. Okay. So life cycle is a well-established tool that can be used to actually increase the efficiency of a product or a service. This basically is out of this manual that I can send you by email. It is more than 6 years now. And this is a project that I coordinated something like 10 years ago. So it showed the potential to improve the sectors, the production strays, and basically we expected 10 years ago, we expected 5 years ago. I don't know if with this pandemic, but we expect that in the future, all the products that will be certified in the European Union have to have a life cycle assessment behind. So a third area of intervention is the eco-design. Eco-design has some resemblances to life cycle assessment, but it's a more kind of managerial and governance tool. It's more devoted to identify where a product or a service can actually be improved and try to see if and try to maximize the impacts. Oops, sorry. Doing this by mimicking the natural world that serves as an inspiration. It has a governance and management oriented perspective. And for instance, in the case of the agricultural field, it can pinpoint the most problematic and promising solutions. You may have something that is easy to improve, but has little impact. So probably if you have to improve a product or a service, probably you'll get to something that has a much bigger impact. Basically, that's what. And I would like also to point out this. This is you probably heard about this circular economy. This is a concept that was coined by the European Commission less than 10 years ago. the first references that I found in the European documents that you can access freely are from 2012 or something like that, so less than 10 years ago. And it actually frames the future of the European Union. You know, if you see the discourses, the official discourses, this is the future. This is the vision, this is the strategy of the European Union for the future. And in the agricultural area is seldom mentioned in this vision, but for me is the touchstone, is the pivotal area that allows the circular economy and to function. And we are not aware of this, and this could be big. This could represent. So basically, there are two things that agriculture has that are essential to this vision and to this strategy. And if you see what is the vision and the strategy of the European Union for the future, this is it. And the two things is, first, agriculture is the universal decomposition media. You know, if you want actually to close the cycle, you have to have the composition, you have to break the connection, the organic connections, and have the nutrients released again. So this is without this, there's no closure of the cycles in the circular economy. And the second thing is that, as I usually say, the agriculture is actually the only activity in the world that actually counteracts the second law of the thermodynamics. You know, you have generally you have the energy is constant. The capacity of the energy to produce work is decreasing with time and with use. And basically, the only way of getting the complexity and to have the first either by burning organic matter, either by biofuels, whatever, the only activity that actually counteracts this degradation of energy is agriculture. So these two things are essential, and that's why generally the problem of you know, the role of agriculture in the circular economy is overlooked, and I think it's essential. It's up to us to demonstrate that we are important. Nobody is going to do so. In terms of the future, I put here three things. Basically, that's something that I'm working on right now, and that's digital platforms, sensors, and engagement. And I will explain. This is from a project that we are just starting, and basically, we have now, we are in the dawn of a new era. The amount of data that we are able to collect, the amount of information that we can process, the use of that data, for instance, for robotics and things alike, is, we are just starting. You know, this is very thrilling, you know. So we have now the capacity, as we never had, to acquire data in real time with very high resolution, not only in what concerns the remote sensing, where you can have drones or where you can have satellite images with unprecedented resolution, but also lots of different sensors. This allows the gathering of relevant information in real time, their incorporation in digital decision-making support tools, the potential to boost a new research and development approach based in the Internet of I'm always in front of it. Internet of Things, machine learning, big data, artificial intelligence, because the amount of data is so big that we need artificial intelligence to treat the data. I give you here two examples that exist already. One of them, which are apps. You know, with your computer, you can now. This is an incredible scientific instrument. You know, for instance, this has temperature sensors. It is even possible to using a special app. It's possible, for instance, to monitor the rainfall intensity. You know, and you don't need to put it in the in the rain. You know, just by the sound, it gives you an idea of the rainfall intensity, for instance. So this is these are two apps that in the MapNet this was improved in a project that an international project that I coordinated, and which is not related to agriculture, but it's a way of showing that you can give your thoughts. You can share them with the world, and then the world can share what they think about some green spaces in cities with you. So this is if you want to download each one of them, feel free. I think there are by now versions in Portuguese. I actually work quite a lot to translating things so that there are Portuguese versions. And the second is the soil quality app. And this, I can tell you because I spent several weeks with one of my collaborators translating almost 1,000 entries to translating them to Portuguese. And basically, with this soil quality app, you can actually, in any place, know what type of soil is there, the quality of the soil, the degradation problems, and how to tackle the degradation problems, okay? And how to, so basically we have the knowledge at the tip of our fingers. This provides specialized support as we never had for our decision making, and allowing for the involvement, and allows for the involvement of practitioners and stakeholders in new participatory approaches and processes. Citizen science is something that is also very dear to me. It has incredible potentialities. I published recently my first work on citizen science, and basically not only the capacity of gathering data and gathering the opinion of the stakeholders and the practitioners is really important, but you know, this is the future. For me, this is very dear to me because this is the future of democracy. We always complain that the democracy could be strength, and now with science, with the involvement, with participatory processes, we have not only the capacity to improve our field, but also to improve society in a way that probably nobody ever heard about. You know, and this is also related to this digital revolution. It allows us things that we never thought about before. It allows you to actually, using apps and things like that, not only gather data, but also to know what people think about, and to, of course, this is how I foresee the future. But there's this capacity of people knowing that their effort is worthful and is taken into consideration, and this is very important if we look to the future. And I'm a strong supporter of democracy, and this is one way that we have to strengthen democracy. For instance, I have going a little behind. For instance, our warning systems using this citizen science approach can improve very, very much by comparison with what we have now. So we are closing in. I would like to to share this with you because I submitted to the Age 2020 1 or 2 years ago a proposal that was not financed, where I actually came to one of the teams that was involved with this. To my knowledge, there are 2 big experiences of this, and one of these guys was in my proposal. So, and I spoke with them quite a lot on this. This photo is actually from the underground in London. They have lines that are not used anymore, so they actually do agriculture there. That was not my guys. The guys with who I work with were from Stockholm, and they were not in the underground. They had an abandoned warehouse. And the thing is, basically this is only possible because of LED lights that are very low, have very low energy consumption, so low that the major problem of them was not the light and the energy, but the water. And they actually told me that, you know, these were 2 guys in a warehouse. They sell fresh vegetables to gourmet restaurants. They made a good living. It paid their salaries, but this was only possible, and this is what I think is most incredible. Is they told me we have a system to actually recycle the water from evapotranspiration. If we didn't have this system, we couldn't have a business because it wouldn't be profitable. But because we can recycle the evapotranspiration, it's enough for us to have a decent salary out of it. So when we think in agriculture, when we think the fresh greens to the market, this is an extreme case. apparently is viable economically. And, you know, it was a kind of shock to me when I spoke with these people. So this is one of the issues. So we are in the dawn of a new era. There are new digital tools, knowledge intensive, that and in terms of business and employment, this is important because it provides business based on you know, knowledge-intensive business, knowledge-intensive jobs. There's an array of opportunities in consulting, developing of new products and systems. There's the scope for research and development, and for instance, product quality management is expected to enter an entire new dimension, and this means business and jobs. So, in conclusion, in addition to the traditional interfaces between agriculture and the environment, where you know, there's this capacity of agriculture to be managed to answer to some of the global problems that the environmental problems that we face nowadays. Agriculture plays a touchstone role in circular economy in its vision and its strategy. I think my conviction is that most of the people that work in this area didn't even realize this. This is big. You know, if you, I usually say that if you, either at European or national or regional level, if you merge the budgets for agriculture and for the environment, probably it's more than 50% of the entire budgets, at least in at the European level is. And so there's lots of opportunities here, or I expect that there are lots of opportunities. And basically, we are at the dawn of a new era where the amount of information allows us to do things that we never thought of, that are a lot beyond what I even expected in my wildest dreams 10 years ago. So thank you very much for your attention. I'm not sure if...
We are a little late, but we still have time for a question. We don't have questions online. I don't know if anyone here has a question. Thank you.
Good morning, Antonio. Speaking? No? We are colleagues. We know each other. And I want to ask you, what's your vision about the problem connected with the young people that doesn't want to learn about agriculture? The first biotech example in the world. Why young people doesn't want to learn about agriculture? What's your vision? And connect with the environment, of course.
Well, yeah, that's a big problem that for all the entire agricultural, not only in Portugal, you know, for instance, in the Netherlands, where they have top universities in the world, they also have some problems attracting students, you know, the quality of students and so on. I've developed quite recently an idea that that I propose that I would expect, we can talk about this later, some of the, I would expect that the president of the Polytechnic of Coimbra that asks us for ideas to change the region. I put forward an idea to involve the secondary and basic schools in the entire region with a project. And I think that's how we have to work. Sometimes and this, you know, I have a few decades of these. I have already many proposals refused because I actually wrote them because they were needed for the society and for the region or for the country, but because of that they are not appealing. They are not so highly innovative. So, for instance, I had several proposals that had very low rates because when I proposed them to FCT, because I wrote them because I thought in my mind, I wrote them because they were needed for the region or for the country, which is probably not the right way of doing it. So we are trying to get more close to, you know, developing these citizen science approaches, and we are trying, and we have done the first steps. We need some money to do that, but probably what needs to be done, and that's a problem of our system, it's not funded by the funding institutions. That's, but yeah, we proposed an idea of involving all the secondary schools and some basic schools in the entire, with themes related to agriculture. And me personally, when I have the opportunity to go to a secondary school and talk about this, you know, I go out of my own pocket, but yeah, this is an education, and you know, we are in a kind of agrarian environment. So allow me to say this: I became aware of this problem when I went to a secondary school not far from here. I think it was in Oliveira do Hospital, and someone told me, oh, when some of our students wants to come, comes to me and says, I want to go to do a course. Someone actually said to me this in my own, to my face. When a student wants to comes to me and says, I want to go to a agrarian school or something, we say, no, don't do that, go to biology, go to history. So it's an education problem.
Thank you. We have to stop now. Thank you very much. So we will end this session. I thank you again. I thank again for Professor Elena Bartkiene from the Lithuanian University of Life Sciences and Professor Antonio Ferrara from the Polytechnic of Coimbra. And thank you all for being with us.